Okay, how's everybody today? Everybody doing all right? Ella. Okay, good question. All right. What should we be studying for the test on Monday? Everything on the exam is coming from our current unit. So everything about sets, intersection, union, complement, logic and truth tables, including what we just finished up, the implication, the equivalence, converse, inverse, contrapositive, just from the current unit. Okay. At some point I'm going to go ahead and start to spiral back in chi-squared and a lot of those other statistical strategies. We just did our focus activity yesterday on correlation. So I did not put anything like that on this. Venn diagrams, all that material, that's what you can expect on the test Monday. All right. So any other questions about the test? That's really good. Okay. All right. Well, we are turning our focus activities in on Friday. At that point, you should have 4. Right now, you got 3. Hopefully, Mr. Yacht will be able to work that with you. If not, then I'll go ahead and do so, and maybe he'll go ahead and continue part of the lesson. The only other thing happening this week on Friday during this class is a fire drill. Okay, so remember, when you leave your stuff here, go down the stairs. We're going to go right to the sidewalk on 19th Street, but then we're going to the east parking lot where the band practices after school, right over there by that trailer. Okay, so even if we don't stick together, make sure to come and find me so I can take the roll on the Navigate Prepared app. And then, we're going to go ahead and start our new lesson today. We're going to talk about probability. Now, we're not going to go very far because I do want to go ahead and give you time in class to work on your assignment, which is due when? Tomorrow. There we go. And then, as soon as we finish up with this probability, we have another lesson called conditional probability, and we'll just continue that through next week as far as we can. Okay? Any questions about what's coming up? Okay, well, let's go ahead and take a look at what we got here. Probability, the relative frequency of an event. How likely is a particular event to occur? All right, so probability P is equal to the number of ways to get the desired outcome over the number of elements in the sample space. Basically, what you want to occur out of every possible outcome that could happen. All right, and then we got some vocabulary words here. The sample space, every possible outcome of an event, which is the universal set. Event, any subset of the sample space. Mutually exclusive. This is a big one, and in fact, in the next lesson, we compare this to what we call independent. But mutually exclusive, 2 events which have no common elements. Okay, so we'll go ahead and kind of skip down here for right now and kind of elaborate on this a little bit. If A and B are both subsets of the universe and are mutually exclusive, then the probability of A and B's union is equal to the probability of A plus the probability of B. If A and B are both subsets of U, again, the group within a group idea, and are not mutually exclusive, then the probability of A and B's union equals the sum of 2 probabilities, but then we subtract the probability of the intersection. Very similar. In fact, you're going to notice as we go through this, we're going to be able to tie a lot of the ideas from sets into probability. So let me kind of give you an example about mutually exclusive. Okay, let's say we have one throw of a die. Okay, so what does that sample space consist of if I throw one die? Yeah, 1 through 6. Okay, so I'll go ahead and do the whole thing. 2, 3, 4, 5, 6. Okay, so 1, 2. I know that's not how it works. There we go. 3, 4, 5, and 6. There we go. Okay, so let's say I go ahead and throw the die twice. The first one here, I'm looking for all the odd numbers. Okay, for the second throw, I'm looking for all the even numbers. Okay, now my question is, would these be mutually exclusive? Okay, yes. Okay, there's not one element that's going to be found here that's also here. When you're thinking about mutually exclusive, you want to think in terms of the intersection. Because here, okay, odd Well, the only things you're going to be looking for are 1, 3, and 5. But then the even, you're looking at 2, 4, and 6. Okay, so they are mutually exclusive. They don't have any of the same possible outcomes. Okay, now if I went ahead and extended on that, what if I changed it a little bit? We still go ahead and throw the die. Okay, but the first time here, let's say I'm looking for an odd number. Okay, but then the other throw, I'm looking for a number less than 4. Okay. Now, would these be mutually exclusive? No, they do have an intersection. They have a common element. That's what we're referring to. Is everybody okay with that? Okay. Mutually exclusive. Pretty straightforward. Okay, what else we got here? Then the other axioms of probability that I haven't brought up. Your probability is going to be, between 0 and 1. Okay, 1, it's a guaranteed occurrence. 0 means there's no chance of that particular event happening. All right. The probability of the null set, okay, is 0. The probability of anything in the universe, well, that's 1. Okay, and then skip it down here to 5. What does that little tick mark mean? The complement. Okay, so the probability of A's complement is equal to 1 minus the probability of A. And that really kind of makes sense because if your universe is made up of either the possibility of one event occurring or not occurring, then if I take 1 and subtract it from 100%, well, then I have the probability of the other. And then it just goes on to say, okay, the probability of one event occurring plus the probability of it not occurring should equal 1. Again, that 1 just represents basically our 100%, the guarantee that it's going to happen. Okay, well, let's just start getting into some examples. Let's see what you guys think. So a fair die is thrown. List the sample space and find the probability of observing. Okay, well, we know the sample space of a fair die is just the 1 through 6 that we had. Okay, but 1 is a multiple of 3. Okay, so what are multiples of 3 that we could have if we go ahead and throw that? 3 and 6. Now I'll go ahead and put the universe here. 1, 2, 3, 4, 5, 6. Okay. Now the number of times this can happen in the universe is equal to 2. Now the probability is to take the number of instances where that could occur, the favorable outcome, and divide it by everything that's possible. Okay, so the probability of getting a multiple of 3 is 2 out of what? How many possibilities were there on the die total? 6. 6 in the universe. So 1 in 3. So according to this probability, if I go ahead and roll a die 3 times, okay, at least once I should be getting a multiple of 3. Okay. Easy, right? Okay. Well, let's go ahead and try 2, an odd number. Okay, so the number in the universe that fits our favorable outcome, what is that? How many odd numbers could we get? 3. Okay, so the probability of an odd number. Okay, we have the 3 favorable outcomes out of the 6 total in the universe. So there is a 1 in 2 probability that you'll get an odd number. Okay. And let me go ahead and write this set right here. 1, 3, 5. Okay. And then we have the questions, are these events mutually exclusive? They are not. Okay, because they have a common outcome, 3 is both a multiple of 3 and an odd number. So these are not mutually exclusive. Yes, ma'am?
Did we write 1 and 2 solve to see if they were mutually exclusive or just stop practice? Right?
Oh, I just went ahead and wrote out the sets. Okay. If you don't need to do that, yeah, don't have to worry about that. Okay. Yes, ma'am?
So it says that the number of elements in the universe are 2 and 3 for both 1 and 2. Would it be?
Yeah, I probably didn't write the notation on that right because I was talking about the number of elements in the universe that are favorable to what we have here. So maybe it would be more appropriate if I put, yeah.
Okay.
Like if we called that set A and set B.
Okay.
Okay.
Sorry, I went.
Maybe something like that. But no, you're absolutely right. I shouldn't have written it with the U. Because that would, anybody who was looking at that would go ahead and say that, well, the number of elements in the universe would be 2 or 3 instead of the 6 that we should have. You're correct about that. Okay. All right. Any other questions? Okay, let's see what else we got. From a bag containing 6 white and 4 red balls, a ball is drawn at random. What's the probability that the ball selected is, okay, red, white, and then not white? Okay, so let's see here. The universe is going to have our 10 balls in here, 6 white, 4 red. So what's the probability of pulling out a red ball? How many possibilities are there to pull out a red? 4 out of the universe, 10. Ooh, that was close. It almost got 2 tenths in here. 2 tenths. Okay. So 2 out of 5 is the probability I'm looking for. Okay. Or basically a 40% chance of that happening. Okay. Now for 2, the probability of pulling out a white ball. Okay, what am I looking at here? Okay, 6 possible outcomes that are white out of the total 10. So this would be 3/5. There you go. Okay. Now, what do you think it's asking us here when it says for the third one, not white? There you go. Again, compare this back to sets, what we've been talking about in the previous unit. We've only got red and white, so not white. What's that refer to? What word am I looking for? The complement. There you go. So the probability of not white okay, is just the probability of pulling out a red ball, which we already previously found to be 2/5. Okay. All right. Questions? Okay. Yes, ma'am.
Whenever you're writing it out, would you do like P parentheses and then the symbol that means like not or
Yeah, you could go ahead if you wanted to. I wrote out not white, but you could put W complement. Yeah, the little tick mark.
yeah, or the I was asking if you could do like the thing that signified that it would.
Oh, the sideways L. I think in this it would probably be more appropriate for your symbol to be that tick mark.
Okay.
Okay. How would you know the difference?
Like when you would use the apostrophe versus.
Well, the apostrophe is used specifically for the complement. I mean, the sideways L is used for the negation, but you really only see those with the truth tables. So, I mean, I guess you could, because the person should understand what it is. I've just never seen it. So, my thought would be probably just use the tick mark. But if somebody in here were to go ahead and write it that way, I wouldn't know what you're trying to apply. So I'd be okay with that.
So you would put white.
That's probably what I would do. Okay. You want to go ahead and try one more, or do we want to go ahead and start looking at our assignment? We want to start looking at the assignment? Okay. So we'll go ahead and stop there. We'll pick up tomorrow with the tree diagram right after the focus activity. Okay, so short lesson today.